Here we are with an introduction to polynomials. We're starting in the fifth unit, and we're going to identify whether functions are polynomials. We're going to find their degree, and then we're going to work with them subtracting, multiplying, adding polynomials. A polynomial means that it is many terms. Poly means many, and nomial comes from the word terms. And so a polynomial can have constants, variables, exponents, but never division by a variable. It can have a division by a constant, a number. So you can see here, these are terms. This is a term. They're separated by a plus or a minus. So this one has 3 terms, so does this one. Okay. This is the leading term because it has the variable with the highest exponent, and a constant term doesn't have a variable in it. This is the leading coefficient, 4. These are called coefficients or numbers in the term that are with the variable. So not everything is a polynomial. Okay. For instance, this one right here is not a polynomial because if you wrote it without a negative exponent, right, you would have a variable in the denominator. So you can't have that. This one, for that same reason, it's not a polynomial because it has a variable in the denominator. This is just short for square root, right? It's inside a radical, like that. But this one is. This one is a polynomial because it obeys all the rules. So once again, not, and then that is what a polynomial looks like. So here are a few more examples of polynomials. Obviously 3x, this is a monomial, only has 1. Binomial, 2 terms. This has 2 terms, and it's okay for the number, the coefficient, to be a fraction. Right? And same here, you can have multiple fractions and decimals and all kinds for coefficients. These are all, and then notice this one is, 5 is a polynomial. It's just a constant term. These are not, because of the y to the negative 2. This is not, because it has a variable in the denominator, both of those, and this one has a radical. The standard form for a polynomial is to put the terms with the highest degree first. All right, so for instance, on this one right here, we would actually put the x to the 6th first, then the 4x to the 3rd, then to the squared, and then the constant is always last. So that would look like x to the 6th plus 4x to the 3rd plus 3x squared minus 7, and the sign goes with the term. And you can see here that if your highest term is just a constant, this is a degree 0 polynomial. If the highest is linear, right, then it's degree 1. If the highest is quadratic, then it's degree 2. If the highest is cubic, or to the 3rd power, it's degree 3. Quartic is degree 4, and quintic is degree 5. And then usually above that, you would just say of degree 6 or 7, whatever it is. But usually the first 0 through 5 get a name, an actual name. To evaluate a polynomial just means plug it in and solve. That's really all it is. So if we did this one right here, we would have 2, and then where the variable is, I'm going to put negative 3 to the 3rd minus negative 3 squared minus 4, negative 3 plus 2. And then you evaluate. So negative 3 to the 3rd power would be negative 3 times negative 3, which is 9, times negative 3, which is negative 27. So 2 times negative 27 minus negative 3 squared is just positive 9. And then a negative 4 times negative 3 is positive 12 plus 2. So I'm going to write it like this. This is negative 54. And negative 9 is, I'm going to add those, so negative 63 plus 14. And so that's 9, I want to say 49 negative. So the evaluation of that polynomial at x equals -3 is -49. Simplifying polynomial expressions, another way of saying that would be combine like terms. Okay, so on this one, what I do that works out really well is just line up the terms that are alike. So I'm going to put the -2x squared underneath that. These are like terms, and these are like terms. And then I'm just going to add them. So this is going to be 2x squared minus 14x minus 3, and you're done. There's no equal sign, so you're just simplifying an expression. You're not solving for x. Now on this other one here, what I'm going to have to do first is I'm going to need to distribute the negative sign and then write it underneath. So for this one, this is going to be -a to the third. This one is going to be positive 3a, and this is going to be -2. So then when I add them, I'm going to have a to the third plus 8a minus 9. So this one is just, once again, just like distributing, right? We're just going to multiply times each term. So this is going to be -4. Usually put the negative sign, then the coefficient, then the variable. 4y to the third minus 2y squared plus 3y. That's it. Multiplying polynomials. Now, I'm going to use the box for this because to me, multiplying this in a box keeps things all nice and organized. Do you have to? No, but it works really well, and I like it. So I'm going to do a and then plus 2, and then up here I'm going to do a squared plus 3a minus 4. And then I'm going to multiply. So I'm going to do a times a squared is a to the third. A times 3a is 3a squared. And then a times -4 is -4a. And then I'll do these on the bottom. So I have 2a squared, I have 6a, and I have -8. And then I'm going to combine like terms. So I have a to the third plus 5a squared. Writing these things made it look like they were negatives, but they're not. I was just placeholders. And then plus 2a minus 8. All right, so I would like for you to try this last one, and when you come to class, I want you to show it to me, that you did it, so that I can mark it in your composition notebook, but that should be at the end, and you can use a box, or you can just use the distributive method to do that, you know, where you do this times these, and this times these, and this times these, or turn them around backwards, either way. But I expect to see that when I come to class. So I'll see you in class.